Good day to you all viewers, and in this video I'm going to show you how to solve this question. Is under differential calculus. Just because they said we have to find the dy over dx. Yes, we've got different notations when it's come to this differential calculus. Okay, of course, yeah, we're going to solve this problem using the short method instead rather of using the long method or the first principle, since it's not stated rather. So we're going to stick to our short method to solve this notation. So they need us to find the dy over dx for this given function. All right, so we're going to apply our rule of differentiation to solve the problem. Just be with me until the end of this video in order for you to understand how to solve a problem like this. All right, so first thing for us to do in this notation before we apply the derivative is to fix the equation first. What we have to put into consideration is to make sure that on our given equation we don't have the radical sign. If we've got a radical sign, we have to remove it because we cannot derivate with the set or the radical sign. And also we have to make sure that the variable this, since we are finding the dy over dx, so this is dx, we have to put into considerations that we are differentiating with respect of this x. So we make sure that on our given function this x must always act as a numerator. If it's the denominator, you have to find a way to represent that term where the x will act at the end as the numerator. Okay, and here unfortunately we have got letter x as our denominator, so we need to fix this. We have got the letter x the denominator, we have to fix it as well. Okay, and the last one we don't have any problem with it because yes, indeed it is acting as the numerator because it have got a denominator of 1 here. So we have to fix these two terms before we apply the differentiation or rule. Okay, so what we're going to do, I'm going to rewrite this but represent these two terms in a different way instead rather of writing them the way it is. So 4 divided by x to the power of 2, it is the same as 4 exponent of 4x to the power of negative 2. This is the same as this. The reason being for me to choose these instead rather, it is because this x squared here on my given original equation, it is acting as a denominator, so I'm avoiding that this x must not be a denominator here. So yes, then now here this is exactly what we have to do. The same applies here. We're going to have 3x exponent of negative 1 because you know that in x it have got an exponent of 1 here. All right, so I'm going to write this x the way it is here. All right, so there we go. So now I'm going to apply the notation dy over dx. dy dy over dx here. I'm going to apply it. So dy over dx now is I'm starting to derivate here now. You know we have to multiply this negative 2 by 4. So it's going to be 4 into negative 2 x, the very same exponent. You know you have to deduct 1 on it. Then you repeat this on each term. So we're going to have negative 3 into negative 1 x minus 1 minus 1 just because this, okay, let me just apply it as well on this one. It have got exponent of 1, coefficient of 1, so it's the same as 1 into 1 x 1 minus 1. All right, then now we have to keep on solving this dy over dx. So 4 multiplied by this, of course, going to give me negative 8 x negative 3. Then this gonna be positive 3x exponent of negative 2 plus x to the power of 0. So when I take it further here, I'm going to have the dy over dx equal to this. Okay, I want to represent this. I want to make sure that at the end of I have the positive exponent with me. So of course it's going to be negative 8x divided by x to the power of 3, then plus 3 divided by x exponent of 2 plus x to the power of this is just 1. There we go. This is how we solve the problem.